So if you remember back when we had a normal distribution and we had a random variable x, right? With a mean of mu and a standard deviation of sigma, we can convert this over to a z distribution, a standard normal distribution. So it was bell-shaped, right? So mu got converted over 0. X got converted over to z, and the standard deviation got converted over to 1. So remember that formula we had. Remember to go from x, convert from x to z. Remember the formula. It was z equals your x value minus your mean, mu, divided by your standard deviation, sigma. Now let's say we have a distribution that's approximately normal, and we're consisting of sample means. So a sampling distribution, or a distribution of sample means. And that has a mean of mu and a standard deviation of sigma divided by the square root of n, where n is the sample size for each sample in your sampling distribution. Now let's say you want to convert that over to z's. So you want to convert from x bar, sample mean, to a z-score. So the mu is going to convert over to a 0. X bar is going to convert over to a z-score. And the standard deviation is going to get converted over to 1. So what formula should you use? Well, you're going to use z equals, instead of x, you're going to have x bar, right? That's your variable in this case, rather than x this time, it's x bar. Minus your mean. What's your mean? It's still mu. And divided by your standard deviation. This time your standard deviation is not sigma, right? Your standard deviation is sigma over root n, so you're going to have sigma over root n. So this is going to be your formula for converting from a sample mean to a z-score. So let me write that down. Convert from a sample mean to a z-score. So the z-score is z, x bar is your sample mean, mu is your population mean, sigma is your sample standard deviation, and square root of n is your sample size. Let's write that down. X bar is your sample mean, the mean of your sample. Mu is the mean of your population. Sigma is the standard deviation of your population. And n is your sample size, the size of the sample that you'll be taking from the population. So make sure you have this formula, very important formula, from going from sample means to z-scores. So we're going to use this to work some problems. So exercises. Suppose the ACT has an average score of 24.1 and a standard deviation of 2.3 points. So the average ACT is 24.1, standard deviation is 2.3. If we randomly select 40 ACT scores. Let's say we randomly pick 40 recent ACT tests and we find out their scores. Determine the probability that their average, that's the sample's average, right? We're taking a sample of size 40, and we want to find the probability that the sample's average, their average, is, number one, less than 24. So what's the probability that their average is less than 24? So let's write down our information. So we have a population of ACT scores, and the mean of that original population is 24.1. And the standard deviation of that population, sigma, is 2.3. And also we know we're taking a sample size here. We're taking a sample size of size 40, right? 40. That's n, right? 40 ACT scores we're randomly selecting. So we want the probability that their average, what is their average? Their average refers to that sample, right? That sample of 40 ACT scores. So their average, that's x bar, right? The sample average is less than, here we're talking about 24. What color? Let's make it yellow. So the first thing I'm going to do, I'm going to convert from x bar to a z-score. So I'm going to convert a sample mean, x bar equals 24, to a z-score. So we had a formula, remember? X bar minus mu over sigma over root n. So let's do that. Z equals x bar minus mu over sigma over square root of n. It's going to be z equals, so in place of x bar, I'm going to put 24 minus 24.1, that's my sample mean. Sigma is going to be 2.3 and over the square root of 40. So if you put this in your calculator, on top you have 24 minus 24.1 is minus 0.1. And on bottom you'll have, make sure you have parentheses, 2.3 over the square root of 40. So you want parentheses around that on bottom. So let's see, what do we get? Plug that in my calculator. Negative 0.1 divided by parentheses 2.3 over the square root of 40. So when I plug that in my calculator, I'm going to get a z-score. It's going to give me a z-score of negative 0.04. You always want to go to two decimal places with z-scores. Let me just double check that. I'll do it one more time so I didn't mess it up. Negative 0.1. I got something different that time. Now I got 0.27. Let me plug it in my calculator one more time. Negative 0.1 divided by parentheses 2.3 divided by the square root of 40. Okay, so the correct calculation should be, let me get rid of this, it should be minus 0.27. So put that correctly in your calculator. So you take negative 0.1, then parentheses 2.3 over the square root of 40. So what this is telling us, if we go back here, this is telling us that the probability is going to be the same as well, if I can get this to work, there it goes. Probability of getting a z-score. So basically, this red x bar turns into a red z is less than, and 24 turns into minus 0.27, minus 0.27. Now, you think about what that is in your table. So as a z-score, you have what, 0 in the center, and minus 0.27 is here on the left. So basically you're getting the area to the left of minus 0.27 right there. And to find that, you just look up minus 0.27 in your z-table. So I'm going to go to my z-table. I have to go to the negative side. Get this to work. It's not working. I got a new update on my iPad, and it's doing all kinds of interesting things. So in some ways it's working better. In some ways it's doing all kinds of things I don't know what it's doing now. Okay. So we look up minus 0.27. And we get an area of 0.3936. So that's our answer, 0.3936. Should be green. So when you're talking about using the central limit theorem, you're talking about a group. You're not talking about an individual being less than 24. You're talking about a group of individuals. So you're talking about 40 entire ACT scores. So what's the probability that 40 ACT scores, their average is less than 24? Okay, let's do another. 2. What's the probability that their average is more than 20? More than 20. So what are we looking for? We're looking for the probability that their average, if you go back and read the question, it was about their average, right? What's their average? It's x bar, the average of the sample, is greater than 20. So the first thing I have to do, I have to convert 20, so a sample mean of 20, to a z-score. So you have to use the conversion formula. Z equals x bar minus mu divided by sigma over root n. Parentheses around sigma for root n. Now let's remember what these different numbers are. So we know x bar is 20. What was mu? Kind of forgot what that was. Let me go back and check. Remember the mu was 24.1. Sigma, which was the original standard deviation of the population, was 2.3. And the size of the sample that we collected was, I think, 40. So we're going to plug in here. First, for x bar, we're going to put 20, and then minus 24.1 over 2.3 over the square root of 40. So let's do 20 minus 24.1. 20 minus 24.1 in your calculator. That's minus 4.1. So we're going to take minus 4.1 and we're going to divide it by the following. 2.3 in parentheses over the square root of 40. Let's plug that in. Negative 4.1 divided by parentheses. Didn't work for me. There it goes. Parentheses. 2.3 divided by square root of 40. So when I do this, I get approximately negative 11.27. Remember, always 2 decimal places. places. I'm going to do that one more time just to be entirely sure in my calculator. Negative 4.1, so on and so forth. Yeah, I got it a second time, negative 11.27. So that's what 20 got converted to. So we can write the probability of getting a z-score, right? X bar got converted to z. 20 got converted to minus 11.27. Now, if you think about what this z-score is and where this probability is in your table, the z-score is going to be minus 11.27. It's way far in the left tail. And you want your z-score to be to the right of that. You want it to be bigger. So your area is here on the right. Now, remember your table doesn't read from the right tail here. Your table reads from the left tail. So if you were to look up a negative 11.27 in your table, you would get the area to the left of negative 11.27. You don't want that. You want the area to the right. So what we have to do, we have to flip this around, right? You have to flip this around. 11.27. And then you want to find the area to the left of positive 11.27. So in conclusion, we want actually probability of z being less than positive 11.27. So what we're going to do, we're going to look up 11.27 in our table, our z table. And we're going to find that area, that probability that corresponds to a z-score of 11.27. Let's do it. Okay, so we got to go to the positive table. Positive table first of all. So I'm going to change to the positive. Is this the positive table? Yeah, it's positive, right? Wait a second, what happens? It goes up to 3.5 and it doesn't go any further. What happens? Where's 11.27 in this table? Well, it says 3.50 and up. So if you have a z-score, a z-score of 3.50 and up, that means your probability is going to be very high, 0.9999, 0.9999. That's what I'm going to write. I have a 0.9999 probability of that happening, of getting an average more than 20. Yeah. So the probability that you get an average more than 20 is very high, almost 99.99%. Okay, let's do another. What's the probability that their average is between 22 and 23? Question. So we want the probability that their average, that's the sample's average of 42 ACT scores, is in between 22 and 23. So first I'm going to have to convert 22 X bar to a z-score. So we're going to use the formula, right? Z equals X bar minus mu divided by sigma over the square root of n. Remember, X bar here is 22. Mu, do you remember what mu is? The population mean? It was 24.1, right? That hasn't changed. The population standard deviation we said was 2.3. And the sample size, n, was 40. That's not going to change. So we're going to take 22 minus 24.1 over 2.3 divided by the square root of 40. We're going to compute that. So what's 22 minus 24.1 minus 2.1. And we're going to divide that by 2.3 over the square root of 40. Make sure you put parentheses around that in the bottom. So here we go, minus 2.1 divided by all of that in blue. So here we're going to get z is minus 5.77, rounded to 2 decimal places. So that's for 22. Now we have to do 23, right? We got 22 right here. Now we have to do 23. Convert a sample mean x bar of 23 to a z-score. We'll go through the same formula procedure. Z equals x bar minus mu over sigma over root n. Again, the population mean was 24.1. The population standard deviation was 2.3. And the sample size was 40. So we're plugging in 23 for x bar this time. Minus 24.1 divided by 2.3 divided by the square root of 40. And make sure you put parentheses around the bottom there. So what is 23 minus 24.1? It's going to be negative 1.1. So we're going to divide that all by 2.3 over the square root of 40. So make sure you keep those parentheses around the bottom. Let's see, negative 1.1 divided by the blue bottom, 2.3 over the square root of 40. So for that, what did I get? I got negative 3.02 for a z-score. So if I go back, my probability is going to be the same as the probability of getting a random z-score between, so for 22, what did we get for a z-score? For 22, we got a z-score of negative 5.755, negative 5.77. And for 23, what did we get? For 23, we got a z-score of negative 3.02. So how do you find the probability here? Remember, you take the probability that z is less than this number first, minus 3.02, minus the probability that z is, yes, less than this number here second, minus 5.77. So basically we're going to have to go in our table and look up negative 3.02, then look up negative 5.77, get those probabilities and subtract them. So here's negative 3.02 first. There it is, negative 3.02, and here's the area, 0.0013, 0.0013, right? Yeah, so the latest edition, the new edition isn't very good, right? It doesn't go back to where I left off at. Okay, I forgot my number already. 0.00, okay, that's a 1.3. A 1.3, my bad. So look what happens. It goes back to the top. It doesn't start doesn't leave off doesn't pick up where I left off. So that's a big shame with this new version. Okay, so 0.0013 when I looked up negative 3.02. Now I gotta look up negative 5.77. What happens when you look up this number, negative 5.77 as a z-score? Okay, here we go. Notice right here, negative 5.77, it doesn't go that far, right? It only goes to negative 3.5. So in that case, since you can't find negative 5.77, you just say negative 3.5 and lower. You take this right here, 0.0001. So we'll put that in. Okay, point. Well, it's blue now for some reason. I don't know why I left it in green, I thought. 0.0001. That's what would happen when we looked up negative 5.77 in our table. We got 0.0001, and you just subtract those numbers. And what do you get? You get 0.0012. So it's a very small probability of getting an average between 22 and 23 for those 40 ACT scores. Very unlikely to get an average between 22 and 23. All right, so I guess we'll